Alrighty, so here we go. So exponential and logistic functions, emphasis on the exponential here. Definition, an exponential function, and you've seen these before, is anything, any function of the form f of x equals a times b to the x. And a is referred to as the initial value, and b is the base. Okay, so this kind of has a power function type look to it. Do you guys remember that from section 2.2, I think it was? What's the difference between what those looked like and what these look like? Yeah. X is now in the exponent, right. Those were like a number times x raised to a number. And this is a number times a number raised to x. Okay? That's the key. The x is in the exponent now. That's what makes it exponential. Okay? Okay, so one thing that you guys are going to be asked to do is to identify if you have an exponential function or not, and if so, what's the initial value, what's the base, that sort of thing. So I'm going to give you guys a few here and see if you can tell me which ones are exponential, which ones are not. All right, let's look at those 5 and see if we can riddle it out. So like I said, first of all, yes or no, is it exponential? And then second of all, if it is, what's the initial value, what's the base? And if it's not, why not? Okay, we'll do that too. Why does it not work? So the first one, f of x equals 3 to the x. Does that fit the definition? Yes, it does. Okay, so yes on that one. Okay, so what's the initial value, what's the base? So a is equal to what, b is equal to what then? Yeah.
A is 1.
Yep, a is 1, b is 3. If there's nothing written out, multiplied in front like that, then a is just 1. Good, okay. What about the second one? Square root of x to the x. Is that exponential? Does it have an x in the exponent? Yeah, so that seems to be okay. But it's not. What's wrong with it? X is also in the base. And the base is supposed to be a what? Just a number. Yeah. So the base cannot be variable. Okay? So this is no. And the reason is it's a variable base. Base has to just be a number. Okay. Third one. Negative 2 times 2 to the x. Yes, that one works. Okay, since it is, what's the initial value for this one? Negative 2. What's the base? 2. Good. Okay. The next one, x to the 5th. Is that exponential? No. Why is it not exponential? Again, variable base. X is not in the exponents, variable base. Yeah, all that stuff. So, yeah, variable base, no x in exponent. So, for both of those reasons, that one doesn't work. Okay, and then the last one. Negative 3 times 2 raised to the x over 2. I heard some yeses. And it's true, it is. It is a yes. Okay, so let's see if you can do this then. What's the initial value? Negative 3. And be careful, what's the base? Oh, you guys are good. Square root of 2 is the base. Does everybody see why that is? Right here, I have 2 raised to the x over 2. I can rewrite that as negative 3 times 2 to the 1/2 to the x. Does everybody see that? That's a rule of exponents you guys have learned before, right? In Algebra 2, you talked about that. It's power of a power is what that's called. So if I can take that 1/2 off that x, bring it down inside, what is 2 to the 1/2 power? That's a square root, right? It's a square root of 2. So this is negative 3 times the square root of 2 to the x. So actually, even though you see just a 2 in the parentheses there, the base is actually the square root of 2. And we're going to write exponential functions that way later. When we do some modeling tomorrow, we're going to deal with having to kind of convert those back and forth a little bit like that. But yeah, good. Okay, so let's talk a little bit about initial value. Why do you suppose that the a is called the initial value? Mm-hmm.
It's what you have when x is 0.
Exactly. It's kind of that starting point, right? So when x is 0, when you have nothing, it's, well, not when you have nothing, but when you're starting, I guess, it's how much you have. So, like, for example, real quick here, if I had an exponential function f of x equals negative 4 times 3 to the x, okay, and I plugged in 0, so f of 0 would be negative 4 times 3 to the 0. And anything to the 0 power is what? 1, right? So really what you have is f of 0 equals negative 4. So that's where we get that name from, is if x is 0, the function's going to come out to that first number every time. Okay? The only thing that I would caution you with here, because if you do this, it doesn't work anymore. These two things are not the same. Don't do that. Why can I not do that? Yeah. Order of operations has something to do with it. Mm-hmm. But it's a little bit more than that, though. This right here, what's being raised to the x power? The 3. Is the negative 4 being raised to the x power? No. You cannot multiply those together unless they're both being raised to the same power. Okay? So it's just the 3. So these two, even though it looks like, oh, multiplication, they're right next to each other, I'm just going to put those together and it's all good. You can't do that. Okay? One's being raised to a power, the other one's not. So they do not go together that way. Okay? It's a very common mistake that people make. If I were to do that, then this whole initial value thing I'm talking about goes out the window too. It doesn't work anymore. So that's a big no-no. And like it is related to order of operations, though, as far as you do the exponent before you multiply and that sort of thing. So technically, you were right too. So okay, I just wanted to make mention of that. Okay, so now that we kind of know what exponential functions are, we can identify them. Can we start like building these up a little bit? So I'll give you an example. So let's find the exponential equation. That goes through zero, 3, and bless you, 112. All right, so every exponential looks like this, unless there's been some kind of a transformation done to it where it's been like shifted up, down, left, right, or something like that. But in general, before any of that kind of business happens, it looks like this. It has to go through the points 0, 3, and 112. So I need to figure out what's A and what's B. So let's start with A. Anybody tell me what A is? Yeah, it's got to be 3, right? Look at this first point that I gave you, 0, 3. So what that means is 3 equals A times B to the 0. Okay, well, what's B to the 0? 1, right? Anything to the 0, even a variable, is 1. So I end up with 3 equals A. So boom, got the first one. I know A is 3. So now I can go back to this first equation, and I'm a little further now. Now I got f of x equals 3 times b to the x. So how do you suppose I can find b now? Yeah, Josh.
X could be 1. After that, for 1 to the 12,
Mm-hmm.
X would have to be 1.
X is 1, and y is 12, right? Yeah. So 12 equals 3 times b to the 1. Okay, and b to the first power is just b, right? So it's 12 equals 3b. So what's b? 4. Yeah. So I've got a, I've got b. So now I've got my function. F of x equals 3 times 4 to the x. That's the one that works. Okay, so the graph of that thing would look something like, let's see, it goes through 3 when x is 0, and then when you're out at 1, it's up to 4. So this exponential function kind of does something like that. Okay, so does that shape look familiar to you guys? We talked about our 12 basic functions and the exponential and how it works. Oh, it's 112, not 14. Sorry. My bad. This is a lot steeper. Hold on. So this goes, and the 1 is probably like out here somewhere. Yeah, and then like maybe 12 is like up here somewhere. Yeah, sorry. I knew exactly what you were going to say. Okay, so in any event, the point I was trying to make, though, is you guys all see the shape of this thing, though, and does that jog your memory banks a little bit from Chapter 1 when we talked about exponentials briefly and what their shapes were? I said memorize the graphs for all of these guys. So they're all going to have this kind of look to them, okay? Now, depending on the values of A and B, the way that this exponential curve is oriented might change, okay? So we're going to investigate that just a little bit here, okay? So how changing the A and the B change things around for us here, okay?